Good morning, good afternoon, and good evening. This is Mr. Payne bringing you Unit 1, Lesson 7, Exponents as Repeated Multiplication. An exponent is a way to indicate repeated multiplication by the same number. Let's take a look at exercise number 1. Write out what each of the following exponents means as an extended product and find its value. So we're going to start off with A, 2 to the 4th. Understand today's topic is all about understanding what that exponent is and what that really means. That means that I want to see that 2 4 times and I want to multiply them. So 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, 8 times 2 is 16. I would like you to try B and C on your own. Of course, just as with numbers, variables can also be raised to exponents. So let's look at exercise number 2. Do the same as in exercise 1, but consider carefully your order of operations. And remember that exponents come before multiplication. I think that you can handle A, B, and C on your own. We're going to start off by looking at D. And I'm going to take my time and I'm going to write that D out all the way first. I'm going to show you what that looks like. So it's 4 times X times X times X times X, because there's 4 X's, times Y times Y times Y. If I were to write that out as a product, extended product, that's what it looks like. Now I would like to take a look at E. I'm going to write this out the long way, and I'm going to see if you can think of the shortcut and what is really happening. So I'm going to say 9x squared, I want to see that 3 times. So 9x squared times 9x squared times 9x squared. And if I want to continue writing that out as an extended product, I would say 9 times x times x times 9 times x times x times 9 times x times x. Now, you can use the commutative property to change your order around of your multiplication and put all your 9's together if you need to, and put all your x's together. But I'm going to leave them just the way they are, just to save a little space on the screen. So now all you have to do is multiply 9 times 9 times 9, which gives me 729, and you can use your calculator on your phone for that. And then add up your x's. So I have 6 x's, so x to the 6th. Take a look at your answer here, what you got, and see if you can come up with a shortcut. So when we discuss this in class, you may have that in mind already. Let's go ahead and take a look at F. It says negative 2x to the 3rd, all raised to the 4th power. So I'm going to say negative 2x cubed times negative 2x cubed times negative 2x cubed times negative 2x cubed. Once again, I can write that out with my x's. So negative 2 times x times x times x times negative 2 times x times x times x times negative 2 times x times x times x times negative 2 with my 3 x's. Negative 2 times negative 2 gives me a positive 4 times negative 2 gives me a negative 8 times a negative 2 gives me a positive 16. And add up your x's, and there should be 12 of them there, so it's positive 16x to the 12th. We're going to talk a little bit about, real quick, when I have a even exponent, when we're dealing with a negative number inside my parentheses, when I like that negative 2, when I have an even exponent, you're always going to have a positive answer. If you had an odd exponent right in here, if you had an odd exponent, say 3, 5, 7, 9, and we were to do that, your answer would come out as a negative answer. Just a little tip, just a little trick on when dealing with exponents. One of the nice aspects of exponents is that they follow very predictable patterns, often known as exponent rules. Figure out the simplest one in the next exercise. You should already have a good idea the way I was writing these out, what that rule may be. I will do A with you, complete B and C on your own. So let's take a look at A. A says x squared times x to the third power. Well, if I were to write that out, it would be x times x times x times x times x. So ultimately my answer is, how many x's are there? X to the fifth power. For exercise number 4, did you notice the pattern? Can you come up with a generic rule for what happens when we multiply two terms that have the same x base? My base is x. We're not dealing with any coefficients in this case. And I'm saying x squared times x to the third. What did I do with my exponents to get an exponent of 5? See the rule? Well, when I have the same base and I multiply my coefficients, I add my exponents. A plus B will give me my answer. Let's put this rule to good use now with exercise number 5 and just use your rule to come up with your answers. A is x to the fourth times x to the ninth, which gives me x to the 13th. That's 4 plus 9. B, x's are my base, so x to the, and if you said 9th, you would be correct. Try C on your own. In exercise 6, we're going to write in our justifications. What property do you see happening? I already mentioned it a couple times throughout, but let's take a look at each individual step. What happens with the 5 and the 2? What's going on is everything's still the same, but it's just changing order. If you remember that changing order means that it's the commutative property, you would be correct. Commutative property. Step 2, you notice that they are putting in parentheses there, and they're just grouping your answers together. We're going to call that the associative property. And the last justification for step number 3, you notice what they did was they multiplied 5 and 2, which gave me 10, and they took their exponents and they added them together. So that is exponent rule number 1. And that's the justification. Exponent rule number 1. Let's look at exercise 7. We're going to rewrite each of the following as equivalent expressions in simplest form. We're not going to go ahead and write them all out. What we're going to notice is that we can multiply my coefficients, or my large numbers, 2 times 8, which is going to give me 16. So multiply my coefficients, and just like in exponent rule number 1, we have the same base of x, so we're going to be able to add 7 and 5, which gives me 12. Now, the only reason we can add these together is because they had the same base, and they're base of 5. Let's take a look at letter C now. This is still tricky, but you may be able to figure out the rule on this guy, or the shortcut. I'm going to write this negative 6x cubed out twice. Negative 6 times negative 6 is going to give me a positive 36. X cubed to x cubed, when you multiply them together with the same bases, I can go ahead and add my exponents, x to the 6th. Remember what I told you earlier in the video, that I have an even exponent, so I'm going to have a positive answer. I hope now, using this example in letter C here, you can see that there is a shortcut to answer that problem. We will start class off on Tuesday talking about that shortcut and seeing if you can use that to your advantage. Please write your WSQ at this time. There is plenty for you to write about today.